Hello, students. Happy April 2nd. Hopefully today, this Thursday, finds you well. Purpose of this video is to review the work from the last little bit with the Pythagorean theorem on pages 55, 56. Again, as always, you can pause, skip ahead, repeat whatever you need. It's going to be a pretty long video as we go over a few examples of problems in each of the sections here. Watch this video as you need. Don't watch it as you don't need, but hopefully you'll have a wonderful day today. If you have questions, one option, let's see if I can zoom in here. Right here, one way we can learn really well is by teaching others, by practicing discussion. So this teaching others, if you're stuck on any of these, talk with each other. Give someone else the opportunity to teach you, and it will help them understand it better as well. And hey, we hope you're currently safe, because we care about you in this lifelong learning environment at home, and we hope you're being responsible citizens, as the government is asking us to be. All right, enough of that. Here we go, page 55, 56. If it seems like I'm flying through it, I am. If you have questions, you can go back and repeat. So find the missing side of these triangles. We can see the right triangle, so we know we can use the Pythagorean theorem here. Round to the nearest 10th. So here we go. Two legs, a squared plus b squared equals the hypotenuse squared, and then you work it through. If you can see this 3, 4, 5 triangle, you already know what x is. If not, you can work it through. 36 plus 64 is that squared, and your calculator will let you know that x squared is 100. So when you take the square root of both sides, x becomes 10. 3, 4, 5, 6, 8, 10 is just 2 times a 3, 4, 5 triangle. Okay, number 3. Or should I do that again? Here we go. 3, 4. Oh, we know what that's going to be. 3 squared plus 4 squared is x squared. Work that through. 9 and 16. You already know that that's 25 is x squared. I'm just racing through because that's another Pythagorean triple. There we go. I know I raced through that. Let's actually do one that requires some work. Number 6. We have two legs here and the hypotenuse. So 7.8 squared plus x squared, the a plus the b equals the c squared, 11.8 squared. And this will actually take some little bit of calculator work. So here we go, 7.8 squared. 60.84 plus the squared is whatever 11.8 squared is. 139.24. To get the x squared by itself now, to get this leg, then b you might call it, you subtract off the 60.84 from both sides. And use a calculator to make sure you won't mess up. 92, that's an 8, 4, and 78.4, I hope. So what have we figured out? We figured out that x squared is 78.4. If I did that math right and take 78.4, take the square root of both sides, gives you x equals square root of 78.4. Rounding to the nearest tenth place, 8 point, whatever that number tells us to do. So 8.9 is the length of the other leg. So we've got it. All right, the next section. Find the missing side of each right triangle, so we know it's a right triangle. C is the hypotenuse, A and B are the legs. There we go, we just set it up. So they don't give us A squared plus B squared equals C squared. There's another 3, 4, 5 triangle. You can take your time and work through it, but I already know that's 5 times 3, 4 times 3, so this is 3 times 3. So A is 9. Just because I'm lazy and I don't want to do all the work on a 3, 4, 5 triangle. I'm thinking about this. Yeah, that's a 3, 4, 5 triangle too. If you do the math, you get 144 and 225. You subtract off the 225, you subtract off the 144. From that, you'll get 81. So a squared is 81, and take the square. Just flying through the way to do it. On this one, a squared plus b squared equals c squared. So 36 plus 64 is c squared. Have you seen the 3, 4, 5 triangle yet? 100 is c squared, so you take the square root of both sides. C is 100. The hypotenuse there is 100. A lot of 3, 4, 5 triangles here. Same thing here, the 13.2 squared plus 8.4 squared is going to be the hypotenuse squared. You can work out the math on that. I think I'm going to actually go ahead and do this one because I want to do one where we're having to manipulate numbers across the equal sign, which gives us 14.8 squared plus b squared is 15.9 squared. So I take the square of that and then I subtract it off. Then I have b squared equals that number. I take the square root of both sides. I'm just going to show you something kind of fun if you're ready for it. I say fun because it's less work for me, and I always like doing less work. And tell me if this, well, I'd say tell me, but it may not make sense. What I'm going to do here and see if this kind of is if I skip too many steps here. If I skip too many steps, then just ignore me and don't feel like you have to work it out. But I know that 15.9 squared, that's this one. I'm taking the square root because I'm doing all these steps in one. 15.9 squared, and then I subtract off, just bring this entire 14.8 squared to the other side. 14.8 squared. I know that if I do that, and then if I take the square root, because that's b squared, and I hit enter, there's the number right there. I didn't write out all the steps. I'm just showing this to show you can do that if you'd like. You have to be careful to make sure you get all the steps in one. It's probably not something to do unless you're getting A's on all your assignments and all your tests. But just one way to see the distance formula, see the hypotenuse there written in the calculator by doing all these steps in one. But again, if that's too much, if I went too fast, please ignore it, pretend I didn't do it, and do it the established way. Okay, state of each triangle is acute, obtuse, or right. Well, we know that obtuse, that means that the hypotenuse is greater. Whoa. And you know that on the right triangle, or on the acute triangle, the C, the hypotenuse is smaller. So we're going to go through each of these and figure out how the hypotenuse compares with the two legs, and then we'll know whether it's obtuse, acute, or if they're equal, if it's right. So the hypotenuse is the longest side. That's over here. On all of these, wherever the longest side is, that's the one that would be the hypotenuse if it occurs. So the 10 squared is simply the 6 squared plus the 6 squared. Are they equal? Well, 36 plus 36, is that equal to 100? Or is 72 equal to 100? No, the 100 is larger. So because the 100 is larger, because the hypotenuse is larger, this is actually an obtuse triangle. Same process on 15, the 10, let's see, 13 is the C, it's the longest leg, so that'll be the hypotenuse if it is one. So 12 squared plus 10 squared is 13 squared. So 144 plus 100 is 169. Maybe. How does that work out? We're trying to figure it out. Well, 244 bigger than 169. So this 13, this is smaller. The C is smaller, which means it's an acute triangle. There we go. We got it. You can do those other two the same way. you might be able to see a 3, 4, 5 triangle here. Okay, turning over to page 56. Same exact concept, same exact problem. There's just not a picture for you. You just have to find out, okay, this longest side, that's the C. The longest side, that's the C. The longest side here, that's the C. And the longest side is the C, the hypotenuse, if it exists. So number 18, oh, it's a 3, 4, 5 triangle. Well, that's a right triangle. Done. The Pythagorean triple already pointed out. If you wanted to do the work, you could say that 3 squared plus 4 squared equals 5 squared, hopefully, maybe, and you see that it does. It does. Okay, on this one, it'd be the 2 smaller sides squared equaling the alleged hypotenuse squared, maybe. We're wondering if they're equal. So 81 plus 144, is that equal to 14 squared? 196. Well, this is 225. It's bigger than 196. So because the 196 is smaller, because the C is smaller, it's an acute triangle. Very pretty. It's cute. And there's that process on those ones. Then this process here, trying to find the diagonal, the length of the diagonal, the converse of the Pythagorean, well, using that over on this one. We'll get that in a second. From one corner up to the other corner, or from one corner down to the other corner, you can use that whole length squared plus width squared plus height squared equals the diagonal squared, or the C squared, however, whatever letters you use, but just the length, width, height, each squared added together is that diagonal squared. Then you can just set up the equation and solve it. So in this one, I'm going to use the 4, 5, and 8. I'm using an 8 there. Some of these numbers are so small, it may be a little hard to accomplish it. 4 squared plus 5 squared is 8 squared. That's the x squared. And then the more steps you write, the better chance you have of getting it right. So 16 plus 25 plus 64. And then add all those up. And if I do that in my head, I'll probably get them wrong. So calculator is a wonderful help of 105. 105 is x squared. Take the square root of both sides. X is something over 10, right? 10 point something. Square root of 105. 10 point, and it said round to the nearest tenth, I think, on the instructions below. We'll use that same set of instructions, 10.2. There you have it. A little bit tougher one on 24, because they give you the diagonal. They give you this number, and you have to find the other. I'm going to use this as a 6 centimeters. I think that's a 6. So we have 8 centimeters. Plus, we don't have this one, x centimeters squared plus 6 centimeters squared is 14.9 centimeters squared. Then we work through the steps. X squared plus 64, I'm just commuting those two additions, plus 36 is whatever 14.9 squared is. And this calculator says 222.01. Okay, so x squared plus 100 is that, and then subtract off the 100 is that, just about there. Take the square root, and we've accomplished it. So 11.0 if we round to the nearest 10. 11.0. Kind of nice that it works out. Just the squared plus the squared plus the squared is the squared. All right. Find the distance between these two sets of points. Find the straight line, the shortest distance between 2 points, straight line. Find that distance. Round to the nth. Well, we can envision a triangle here, a right triangle. I just call that the hypotenuse. You just take a squared plus b squared equaling the c squared. So from here to here, this is a distance of 1, 2, 3. You can count it. 3 squared plus 1, 2, 3, 4, 5 plus 5 squared. That's going to give us the distance squared. So 9 plus 25, which is the same thing as 34, is c squared. Taking the square root gives us the square root of 34. Something what? Less than 6, 5.8 or something? We don't round up, so 5.8. C is rounded to the nearest tenth, 5.8. 26, real difficult. Find the distance between the 2 points. Oh, we already have it. If this one's on the 2, and this one's on the -4, from 2 to -4, that's a distance of 6. From there to there, you can count each unit if you want. Distance is 6. Nice and easy, no diagonal. Wonderful. 27, finding these distances from here to here and there to there. You can count the units. I can see that it goes from 3 on the y-axis down to -5, so that's a distance of 8. If you counted 1, 2, 3, 4, 5, 6, 7, 8, but you can just count where it's at on the y-axis. And then on the x-axis, it's over here. It's from -5 to 4, so that's 9. Or if you counted it over, 1, 2, 3, 4, 5, 6, 7, 8, 9. Either way, you get what you need for 8 squared plus 9 squared equals the distance squared. 64 and 81 is c squared, which is 145. Well, take the square root of both sides. You know it's 12 something because 12 squared is 144. So c is 12 point what? 0? $12.0. You got it. And then finally down here, trying to find out where you're just given the ordered pairs. If you want, you could draw a picture here and find the point 1, 4. Let's see, 1, 4, and the point 6, 1, about right there. You kind of envision that distance, and then you can count down and count over. That is one way to figure out the distance between them. Another way is just figuring out on the x, going across this leg right here on this x, 1 to 6, how many units that? Oh, that's just 5. And you would have gotten that if you draw a picture and count over. It's 5 away. 1 to 6 is 5. You can subtract them. 1 minus 6, -5. It's a distance of 5. Or if you go this way, 6 to 1, it's a distance of 5. And you subtract them. From 4 to 1, so it's 5 squared plus, on the y-axis, going up and down, the y number, 1 to 4, that's a distance of 3, whether you say 4 minus 1, that gets you 3, or 1 minus 4, that's -3. Either way you count, it's 3 units. So 5 squared plus 3 squared is the distance squared, which gives us 25 plus 9, or 34, is c squared. Simply take the square root. That looks like a familiar number, the square root of 34. Pushing the number again above the enter key gives you 5.8. I almost made it, didn't quite make it. Lights turned off. There's no one in here to think that it's moving. I'm not moving enough. So I'll go turn on the lights and then we'll do number 32. Hey, lights, turn on. Thank you. That whole voice thing, oh, it's wonderful. All right. Last but not least, here we go. If you want to draw a picture again, -7 down here, and 3, -1 is over here. the distance is something like that. But if you just say, how far is it from -7 to 3, or -7 minus 3, -10, or it's a distance of 10, from 7 to 0, and then 3 more. So it's a distance of 10. The y distance from -7 to -1, how far is it going up and down? -7 minus -1, it's a distance of 6. Or if you go the other way, -1 minus -7, either way you'll get 6 squared. And that all turns out to be c squared. Again, whatever works best for you, drawing a picture or subtracting the numbers. And because we're talking about distance, absolute value, just use the absolute value of that. Throwing a lot at you, I know, as a review. The process is the same, though. How far from this x point to this x point? How far is it from this y point to this y point? And those are the two numbers. So 136, c squared. 136 is c squared. Take the square root, try to estimate in your mind. If you've got this process down just as a level 4, let's see, 144 is 12, and 121 is 11. So it's going to be about 11 point what? It's a little closer to this, 11.6 maybe. Let's see. Change the format of a number, pushing the number above the enter sign. 11.66, and it rounds, the nearest tenth rounds to 11.7. There you go. I know sometimes entering numbers in Canvas, and you're entering it the way you think it's right. Maybe Canvas only wants to see it a certain way. But 11.7 rounded to the nearest tenth. There you go. There's the review. That's 20 minutes. It's kind of a long class period. If you needed all that time, I'm glad you took advantage of it. If you didn't need it all, you probably aren't watching this video anyway. So I'll just say, have a wonderful day. Enjoy April 2nd, and consider yourself well prepared for the test tomorrow. Bye-bye.